Okay, you already sort of know this from going through the textbook, those couple pages that you did on your own. But let's get some notes in your comp book and let's talk about some of the features of what you probably know. So we're going to compare the three forms. We're going to compare vertex, standard, and intercept form. All right, so the first one, this is in your trifold vertex form. What are some of the benefits when you're looking at this form? Well, what you've got is you can identify the concavity, which is that A, and you can also identify your vertex, which is H and K. So you can use that to graph. By the way, this is a word I haven't been using before. Concavity is just a fancy way of talking about whether it opens up or down. If it opens up, it's positive. Some people say it looks like a smile, it's positive. If it opens down, it's negative, and that's a frowny negative. Okay, moving on. Standard form, we can still see the concavity. We still have our A. And it actually also tells you the y-intercept, which we haven't talked about before. And that can be referred to as O, comma, C. How does that work? Well, think about it. If you're looking at your y-intercept, then when you're graphing it, you're asking, well, when does it intercept with the y-axis? So you're looking for when does x have a value of 0, right? When does x have a value of 0? Well, how can we figure that out? Well, if we take our function and we plug 0 in for x, let's take a look at what happens. If we plug 0 in for x, if we look at for f of 0, we get a times 0 squared plus b times 0 plus c. Oh, those are going to be zeros, aren't they? So f of 0 is going to be c. Simple enough. Even if we had an a there, it would still be c. So that's going to tell us our intercept. Intercept form, when we factor it and we get our two, these are x-intercepts. When we're talking about intercept form for quadratic equations, we're talking about our 1, 2, or 0 x-intercepts. So what benefits from this? Well, again, it gives us our concavity with A, and it gives us our x-intercepts, which are p, comma 0 and q, comma 0. And some of you were confused about this, so I'm going to take a little minute to talk about this here. So when we were looking for those intercepts, pardon me, what are we looking for? We're looking for when f of x is 0, right? Because if we graphed it, we're looking for when is y 0. So when is f of x 0? So we can plug in 0 for that. If we have 0 equals that function, that expression, well, what did we learn before? We used the 0 product property. That means that x minus 5 has to equal 0, or x plus 2 has to equal 0, right? Well, when does that happen? That happens when x equals 5, or when x equals negative 2, right? That's the 0 product property. Well, now we're just saying it slightly differently. We're saying p equals 5, because that would turn this to 0, and q equals negative 2, which would turn that to 0. Right now, we can look at it simply as p and q this way, but if you have something else before your x, it gets a little more complicated. So be sure to factor out to be safest. Okay, p is 5 and q is negative 2. So that gives us our x-intercepts. All right. So now let's go ahead and practice using all three forms to graph the function. Let's first use vertex form. And then here's a reminder, that's what vertex form is. We get our h and our k. So, first thing you need to do to convert this standard form to vertex form, you need to complete the square. So, I have f of x equals x squared minus 4x minus 5. Well, how am I going to complete the square? I'm going to rewrite that, leaving space. I'm going to move that negative 5 off. And so what is the c that I have to add to complete the square? Well, negative 4, half of negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add and subtract 4. And now I'm going to deal with just this part, and I'm going to take the square root of this. So I'll have f of x equals x minus 2 squared, because that gives us this expression. And now I just have to deal with my -5 and -4, and that's going to give me -9. All right, now I have my h and my k. Oh, we also know that it's concave up because a is 1, positive, and we have our vertex of 2, -9. Remember, opposite of this and that. So I can plot, really quickly. I'm going to remember to label my axes. I'm going to get lazy later. And there's my vertex, 2, -9. I should label that point, 2, -9. There's my vertex. And now what do I have to do to continue graphing? Well, I know that it's going to open up, but that's not a lot. So I'm going to have to use my pattern. Over 1, up 1, over 1, up 3, over 1, up 5, however many, to be however accurate you need to be, and then I can graph my parabola. Okay, let's look at standard form. And standard form right now is not your friend. Okay, so what I can do is I can look for my intercept. And I know some of you already see the y-intercept. But what I should technically do is rewrite the function. F of x equals x squared minus 4x minus 5, and then solve for f of 0. But as you already knew, f of 0 is going to equal -5. So now I have an intercept, a y-intercept, of 0, -5. And I can plot that point. And what good does that do me? Well, right now it doesn't do me a great deal of good. There are things that you can do from standard form, to find the axis of symmetry, to solve for your vertex. Don't. Seriously, don't graph it from this form right now. Okay? Don't need to. But what you could do, how does this become useful? If you graph it from HK or from x-intercept form, this is a great way to check your work. Just look for, do I have C as my y-intercept? And if after you graph it you have that, you can feel pretty good that you're on the right path. So you can use it as a good double check. All right, last form is we are dealing with intercept form. Again, this is x-intercepts. So remember, for intercept form, I have factored out A, and I have my factors of the expression that's left after factoring out my greatest common factor. Okay, so what I will do is I will factor and set f of x equal to 0 in order to find the two intercepts. It's a fancy way of saying look for P and Q. So here's my function, f of x equals x squared minus 4x minus 5. And now if I can, I'm going to go ahead and think about this. Well, this is going to turn into f of x equals x minus 5 and x plus 1. Remember when we used to do that? Let's see, those two multiply, minus 5 and 1 gives me -5. And if I add them, minus 5 plus 1 gives me -4x. Perfect. And there's my p equals 5, q equals -1. Again, what am I really doing? I'm setting f of x equal to 0. And I'm thinking about what values of x give me a y value of 0. Right? Because this would have to be 5, that would have to be -1. But again, let's keep it simple and just say p equals 5, q equals -1. And that's going to give me my two intercepts, 5, 0, and -1, 0. And now I'm going to use the axis of symmetry to find my vertex. Well, what's halfway between 5 and -1? If I add those, I get 4. 4 divided by 2 is 2. All right. So I'm going to look for f of 2 equals 2 squared minus 4 times 2 minus 5. I have no idea what that rogue parentheses is doing there. Don't need that. There we go. Now I can just solve. So f of 2 equals 4 minus 8 minus 5, which equals -9. So when x is 2, y is 9. So there's my vertex, 2, -9. I now have 3 points. Sometimes you're going to hear use 3 points to graph the function. This is the 3 points you would want to use, intercept. So there's my vertex. There's my x-intercepts, and now I can approximate my parabola. And if I wanted to, if I felt like, I could look at that c and say, is c -5? Yeah, that looks about there. And I can feel good about having probably gotten everything right. All right, so different options. Figure out what works for you. Figure out what is applicable for the function that you're given. What's the easiest way for you to solve? And think about also how accurate do you need to be with what you're solving? And that might also make the difference for you. All right, see you guys in class.